This is a video presentation of Chapter 4, Section 1 in the 7th grade textbook entitled Ratios. Okay, so let's discuss where we've been and where we're going here. We just finished up dealing with fractions, adding, subtracting, multiplying, and dividing at the end of the last unit. And now all of a sudden we're on to this new topic called ratios. What is a ratio? A ratio is a comparison of two quantities by division. Well, that makes good sense from where we just came from, because remember what a fraction is. A fraction, if we think about it, how do we convert a fraction into a decimal? We divide. We divide the numerator by the denominator. All right? That's a comparison of two quantities by division. All right? And a ratio is also a comparison of two quantities by division. So these two topics flow right in with one another. There's lots of different ways we actually can write ratios, and a fraction is actually one of them. So once again, just for the proof that these two topics belong right next to each other. So here we go into 4.1, ratios, a comparison of two quantities by division. So the first question here says 20 students are asked to choose their favorite music category. 8 choose pop, 7 choose hip hop, and 5 choose rock. Write each ratio in all three forms. So as I already said, one of the ways to write a ratio is to present it just like a fraction, a number over a number. There are two other ways to present a ratio. All right? In lieu of the fraction bar, you can write the word 2, T-O. So comparing two numbers like 2 to 3 or 6 to 9 or whatever we want. In lieu of the fraction bar, you can also use the colon, the double dot. 2:3, 6:9. Those are the three ways to write a ratio, as a fraction, with the colon, or with the word 2. It can also be reduced just like a fraction, and it doesn't really matter which form it's written in. Now, it's not exactly a pure fraction, and the reason why is because ratios can end up involving decimals. All right, and a lot of the time when we see that in this type of class, we'll see that when they start talking about a comparison involving money. And that's the one thing that makes it a little bit different than a fraction. So even though I'm going to call it a fraction, sometimes I might even call it numerator and denominator, it's not exactly a fraction in that you can get away with that decimal thing that you could not in a normal fraction. All right, so back to the question. The question here in part A is asking me to compare a ratio, or write a ratio, comparing the number of people that like rock to the number that like hip hop. So as you can see in the question here, there are 5 people that chose rock and 7 that chose hip hop. So the ratio of rock to hip hop fans is 5 to 7. So we're going to write that in all three ways now. 5 to 7, T-O-7, 5:7, and 5/7. What's important is you write it in the same order that they present the question. Since they gave the rock number or the rock category first, you have to give the rock number first. Since they gave the hip-hop category second, they have to give you the hip-hop number second. You have to keep that same order that the question is presented in. All right, here's the B question, hip-hop to pop. So again, looking at that same paragraph, there were 7 that chose hip-hop and 8 that chose pop. So the ratio for hip-hop to pop is going to compare 7 and 8. And you're going to write that in all three ways. So 7/8 with a fraction, 7 to 8, T-O-8, and 7:8. Finally, in part C, it's asking us to compare rock to pop and hip-hop. Now, when it says pop and hip-hop, obviously that means you're going to combine the two results for those categories. So the rock category came in at 5, pop came in at 8, and hip-hop came in at 7. So we're going to combine those 8 and 7 numbers to get 15. So the rock category ends up being 5, pop and hip-hop together, 15. All right, so we're comparing 5 and 15 in my ratio here, which I'm going to write all three ways. 5/15, 5 to 15, and 5:15. Now, what's not set up there that can actually be done is, since in that one I'm comparing 5 and 15, and 5 and 15 have a greatest common factor of 5, you can actually reduce that to 1/3. or 1, 2, 3, or 1:3. The comparison is the same. Right? For 5 rock fans, there are 15 pop and hip hop fans. All right? If I reduce it to 1 to 3, it says for every 1 rock fan, there would then be 3 pop and hip hop fans. And as you can see, since those fractions are equivalent, when we bubble that up, it still comes out to 5 over 15. So that's why the ratios would be equivalent. Here's question number 2. It says, on average, most people can read about 600 words in 3 minutes. Write the ratio of words to minutes in all 3 forms, and write your answers in simplest form. So this is practice really with the simplest form idea that we've been talking about, because now we should have a pretty good understanding of how to write a ratio. Now, let's see here the second statement. It says to write the ratio of words to minutes in all 3 forms. So they're telling me how to set up my ratio there. They want the words thing first, they want the minutes thing second. All right, now we go back to the first sentence, and it says 600 words, 3 minutes. All right, so when we're comparing words to minutes, it's going to be 600 words compared to 3 minutes, or 600 over 3. Well, the question said simplest form, which is a good indicator that this guy can be reduced, and indeed it can. As you can see, you can chop 3 out of both 603. And when they chop 3 out of both 600 and 3, it reduces down to 201, respectively. So the simplest form of this guy is 200 over 1, or in other words, the average person can read about 200 words every minute. Writing the ratio in simplest form, 200 over 1, 202, T01, and 200:1. Number 3, honey, lemon, cough drops come in packages of 30 drops per 10-ounce bag. Cherry cough drops come in packages of 24 drops per 6-ounce bag. Tell which package has the greater ratio of drops to ounces. So if we're comparing a 10-ounce bag and a 6-ounce bag, it's kind of hard to compare because they're different sizes. So what they're doing here is they're going to figure out how many drops am I actually getting per ounce. And the question is asking which package has the greater ratio of drops to ounces. So they're asking me, in essence, in which package am I getting more drops per 1 ounce? So they write 2 ratios that compare drops to ounces. Why? Well, because the last sentence here says they want me to compare drops to ounces. So in the first sentence, it says that the honey lemon package is 30 drops per 10 ounces. So that's why the fraction is written as 30 drops over 10 ounces. In the second sentence, it says for the cherry cough drops that they're 24 drops per 6 ounces. So that's why the fraction is written as 24 over 6. Now again, the goal here is the same, to look at how many we're getting per 1 ounce. So both of these bottom numbers, denominators, are both going to become 1 here. So if we're looking at this one on the top, I'm saying, what am I dividing out to make this this bottom number become a 1? Well, to go from 10 to 1, you divide by 10. So you have to do the same thing in the top. 30 divided by 10 is 3. To make the bottom number down here for cherry become 1, what did I divide by? Well, to go from 6 to 1, I would have had to divide by 6. So I'm going to divide the top by 6 as well. 24 divided by 6 is 4. So when I buy the honey drops, I'm getting 3 drops per ounce. When I buy the cherry drops, I'm getting 4 drops per ounce. Well, obviously, 4 here indicates that I'm getting a better amount per ounce here. So in this case, since 4 is bigger than 3, once I have the denominators the same, we find out that we're getting more, greater ratio of drops to ounces when we buy the cherry cough drops. All right, so let's go ahead and finish this up by looking at the check it out examples here. Number 1 says 19 students are asked to choose their favorite sport. 9 choose rock climbing, 4 choose kite surfing, and 6 choose snowboarding. Write the ratio in all 3 forms. And they want us to compare snowboarding to rock climbing. So the kite surfing number, I don't even need. All right, I just need the snowboarding number, which is 6, and the rock climbing number, which is 9. So I'm writing a ratio comparing 6 and 9. Now they asked me to write it in all 3 forms, so I'm going to write it as a fraction, 6 over 9, with the word 2, 6 to 9, and with the colon, 6 colon 9. Now you might be saying, well, wait a minute, why didn't you reduce? You can reduce if you want to. You can write 2 to 3, 2 colon 3, and 2 over 3. But the question doesn't ask about simplest form. Where they're actually going to ask me about simplest form is in question number 2. And that question says, at Casitas Middle School, there are 456 students for 152 microscopes. Write the ratio of students to microscopes in all 3 forms. Write the answer in the simplest form. So, as you can see, they put 456 students over 152 microscopes. Why? Because in the second sentence there, they're asking me to write the ratio that it compares students first and then microscopes. And they want that guy to be in simplest form, so reduce that as much as possible. Well, I can divide 152 out of both of those to end up with 3 over 1. So we know it reduces down to 3 over 1. Now we've just got to get the other forms. Obviously, fraction is one of the forms, so 3 over 1 is good. 3 to 1, 3T01 would be a second acceptable answer. And 3 colon 1 would also be an acceptable answer. Here's the final question. It says jelly beans come in small packages of 25 per 5-ounce package and large packages 56 per 8-ounce package. Compare the ratio of jelly beans per ounce for each of the packages. Okay, so they want us to compare the ratio of jelly beans per ounce. So that's the order they want me to write my ratios. The number of jelly beans compared to the number of ounces. Jelly beans first, ounces second. So for the small package, there's 25 jelly beans in 5 ounces. So they write a fraction that's got 25 over 5. And then when they get to the large package, they get 56 jelly beans per 8 ounces. So that's a ratio comparing 56 and 8. Now both of those are reducible. Of course we need to reduce because we're trying to figure out, in this case, how many I'm getting per ounce or per 1 ounce. So the tip here is they want the bottom number to become 1, so you're going to divide by whatever the bottom number is, just like the question we did a minute ago. So with this 25 over 5, to make the bottom number become 1, I'm going to divide by 5, top and bottom, 5 over 1. So that means I'm getting 5 jelly beans for 1 ounce in the small package. When I come over here and look at the large package, since the bottom number is 8, I'm going to divide the top and the bottom by 8. That's how I'm going to get 7 over 1. Well, that means I'm getting 7 jelly beans per ounce. Small package 5 per ounce, large package 7 per ounce. Well, that means in the large size package, I'm getting more jelly beans per ounce.